Hey guys, we're back with the notes for 9.4. We are on the second page, page 21, and we are working on the multiplying and dividing with rational expressions, okay? All right, so if you would, pause the screen for just a second, copy down the 3 steps for multiplying and kind of the added note here for dividing. Perfect. Okay, so let's go ahead and look at this. We're basically going to follow the exact same steps for simplifying. This is just a multiplication problem. So when I say put everything else back together, I'm really meaning multiply everything across back together. Okay? All right, let's look at problem 1, or problem A. Problem A, first thing we're going to do is factor everything that we have and put it all together. Okay, there's no real factoring going on in this problem because it's just a monomial over a monomial and a monomial over a monomial. There's no plus, no minus. Okay, so here's what I would do. I would multiply across everything together and then see what you can eliminate. You technically can eliminate from the beginning. Like for instance, if I see right away that I have x to the third and x to the third that can go away, that's great. If I see that I have a y squared and a y that I can eliminate, that's great. If I see that I can have 2 x's on top and I can get rid of just 1 on bottom, that works. If I notice that 6 and 8 is really the same as 3/4, that's great. And I can go very, 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 very simply and say, all right, I got 9x over 4. That's the answer. But most people don't see that all. So let me show you how you would do it full out, okay? First thing we would do is multiply everything together. So 6 and 3 is 18. I have a total of 5 x's here on the top. I have a total of 2 y's on the top. Down on the bottom, I got 8. X to the 4th, I have 4 x's on the bottom and only 2 y's. Once you get to here, you could solve this the exact same way that we did in Unit 9. We could simplify this fraction. 18 over 8 simplifies to 9 over 4. I would cancel and subtract my x's, so 5 on top minus 4 on bottom gives me just 1 on top. And then my y's cancel completely. I get the exact same answer. It does not matter which way you do it, okay? All right, let's go to B. For B, B's a little bit longer, so this is where we're going to start employing all of these steps, okay? All right, first thing I'm going to do is draw a big fraction line because I'm going to factor all of this crap apart, okay? All right. Starting with this guy. I'm looking for numbers that multiply to make a 3, add to make a 4. That's going to be x plus 1 and an x plus 3. Let's go down to the bottom. I'm looking numbers that multiply to make a 6, add to make a 5. All right, that's a 2 and a 3. So x plus 2, x plus 3. Let's move over to this one. Multiply to make a negative 10, add to make a negative 3. So that's a 5 and a 2. Looks like I'm going to need the 5 to be negative. And then final one down here, there's only 2 pieces, okay, but they definitely have something in common, so it's not a difference of squares or anything. Looks like I can take out an x like a GCF, and that would leave me with an x and a plus 1. All right, now that I have all the pieces written out, and this is still multiplying, everything's just multiplying together with all the parentheses, I'm going to start looking for stuff to cancel. X plus 1, yep, find him on the bottom. X plus 3, yep, I find him on the bottom. X minus 5, nope, he's going to stay. X plus 2, yep, find him on the bottom. All those guys leave. Only thing left on the top is x minus 5, and only thing left on the bottom is an x. I don't have to do anything spicy on this one. There's nothing to multiply back together. This is my answer. Okay? All right, let's look at C. All right, C, everything is polynomials, everything is factorable, basically. So I'm going to go ahead and draw a long fraction, multiplying this all together, and we're going to do one piece at a time. All right, this guy is a difference of cubes. Again, you're supposed to know these rules. So if I think about this like an x is my A, a 5 is my B, I keep the sign on the first one, so x minus 5. For the second one, I have a longer parentheses. We're going to square the first, square the last, and we're going to put them together with a change of sign. So instead of a minus, I put a plus, and a 5x goes together. Now, instead of 5 squared, I am going to go ahead and make that a 25. Okay? I can't factor that parenthesis anymore, so he gets to stay. Let's look at the next one. If I come down here, starting with a plain x squared, so I'm multiplying to make a 14, adding to make a 9. It's an x plus 2, x plus 7. Moving back up to the top. Multiply to make an 8, add to make a 6. That's going to be 2 and 4. So x plus 2, x plus 4. And down on the bottom, multiply to make a negative 20, add to make a negative 1. It's a 4 and a 5. The 5's going to need to be negative. So negative 5 and an x plus 4. All right, everything is multiplying together right now. Everything is all in one long fraction. I'm ready to cancel. X minus 5, yep, he's on the bottom. X squared plus 5x plus 25, nope. X plus 2, yep, he's on the bottom. X plus 4, yep, he's on the bottom. So the only things I have left, I don't really have to put back together. They are singular. So x squared plus 5x plus 25. There's nothing else on the top that I need to multiply together with him. Same thing on the bottom. X plus 7 is the only thing there. So I don't need to do anything else. That is my final answer. No parentheses. Okay. All right, if you need to pause that top multiplication section, do that now. We are going to build on that with division. So division, I'm not doing anything different. It's the exact same steps. The only issue is you have to make sure that you switch division to a multiplication problem by multiplying by the reciprocal of the divisor. That's a whole bunch of math language that really just means flip the second fraction, okay? So when I write this out, I'm going to think about taking this guy and flipping him. Some people should probably write this out to start, okay? So some of us, it would probably be in our best interest to go ahead and copy it down the first time, the exact same way, just with the bottom on the top and the top on the bottom. If you can do it without that, that is totally fine, but you will need to make sure that the second piece gets flipped, okay? All right, moving on to the same way we were working before. When you have monomials, you can put everything together or you can simplify from the beginning. I'm going to simplify from the beginning, okay? All right, so if I look at this guy right now, I'm noticing that there's 2 x's on the top, there's a squared, and there's also a squared on the bottom. If I'm looking at the y's, I see 3 on top, can cancel with 1, 2, 3 off the bottom. And I'm looking that I have 3 x's on the top, 1 x on the bottom, so I'm going to take off 3, leave him with a 2. 2 is his exponent because I'm taking one of them away, okay? All right, when it comes to all of these other fancy multiplications, here's what a lot of people like to do. A lot of people can simplify those out and divide them one at a time. So for instance, I see 54 as like a 9 times 6, and I see 81 like a 9 times 9. I see 24, I'm trying to use the same numbers, so I could say a 6 times 4, that would get rid of the 6, and the 16 could be like a 4 times 4. Because now if I do that, I can get rid of 1 9 on top and bottom, 1 6 on top and bottom, and 1 4 on top and bottom. We can put together what's left and then see if we can simplify any farther, okay? All right, so looking at what's left on top, I have that 4, I have a y, and then I have 2 x's. So let me show you where those are. I have this 4, this y, and these 2 x's. Moving across the bottom, I have a 9, and I think that's it. Just that 9 on bottom. So in this case, I can't simplify anymore. 4 over 9, x squared and y. Technically, you would want that y centered, and technically, you would always put the y at the end. We usually write letters alphabetically, so from x, then y. Okay? All right, but that's the final answer. If you need to pause that screen, write it down, go ahead. Otherwise, if you wanted to multiply everything together first and do all your x's total, all your y's total, and subtract, that's the exact same thing. Okay? All right, let's do B. All right, I'm going to do this a different way, and I'm going to show you how you can do it and flip at the same time, in case you're interested. Okay, I'm going to highlight who's going on the top in blue. So this guy's on the top, and when I flip, this guy's going on the top. For the bottom, orange is going on the bottom. This guy, when I flip him, is going on the bottom. So let's break these apart. I'm doing the top one first. So 9x squared, I'm going to write that out as 9xx. That way I know there's 2 of them up there. I'm also going to put this other blue guy on top. So if I write him out, he has a GCF of an x. And if I take that out, I'm going to end up with 2x minus 1. All right, those are all my factors across the top. Let's do orange now. All right, so if I factor this guy first, I'm taking out a 3. If I do that, I'm left with 2x minus 1. This other guy is going to go on the bottom. If I take that out, I'm pulling out a 3x as a GCF. I'm left with an x minus 4. All right, so looking at this, I'm seeing, is there anything I can cancel? Well, yeah. A 9 is the same as 3 times 3, so I can get rid of that. I can get rid of 1x on top and this 1x on bottom. I can also get rid of the 2x minus 1, 2x minus 1. So the only thing that I have left when I make my final answer is I have an x squared on top, so 2x's left over, and then I have that x minus 4 on the bottom. No parentheses needed, nothing to multiply back together except these x's right here. All right, we got one more. All right, I'm going to do C the same way I did that middle one, so I'm going to flip as I write down my first step. So the oranges are going to go on the bottom, the blues are going to go on the top, and I'm going to start with a long fraction line. Okay, switching it to multiplication. So starting with blue on top, if we need to do a swing and divide, I'm going to multiply 3 times 1, so I'm looking at x squared plus 4x plus 3, breaking it into x plus 1 and x plus 3, and then pulling out that 3 again. So I'm looking at 3x plus 1 and an x plus 1. That's my top guy. Okay, my other top guy is going to be this other blue one. Ooh. So now we're going to factor this one. So he's very basic. He has an x to start, so multiply to make a 12, add up to make an 8 is going to be 6 and 2. X plus 6, x plus 2. Now let's go to orange. All right, starting with this guy on bottom, that's a difference of squares, so x plus 2, x minus 2. Moving over to this guy, he doesn't factor. X plus 1 is just what it is, x plus 1. All right, looking for things that will cancel. The x plus 2's on top and bottom cancel. The x plus 1's on top and bottom cancel. But here is where the first time we see something that has to be multiplied back together, okay? So let's write it what it looks like now. 3x plus 1, x plus 6, on top of the x minus 2. But when we multiply this back together and make our final answer, we're going to need to FOIL this. So 3x is 3x squared. If I do 3 times 6, that's 18x, and 1x makes 19x, and 1 and 6 makes 6. My whole thing on the bottom is going to be over x minus 2. This is my final answer. If you need to pause anything on the division, go ahead and copy that down now. We are going to move into the last 2 problems, which is our complex fractions. Perfect. All right, complex fractions are not complicated or complex. They're just a fraction within a fraction. So much easier if you will write these out horizontal to begin with. So I'm doing 1/3 divided by 5/7. Same thing here. I am doing 6 over x minus 1 divided by 3 over x. Now we've learned that we need to flip them. So I need to keep the first one, flip the second fraction over. Again, keep the first one, flip the second fraction over. Okay? Then I can multiply across just like we normally would. So if I multiply across here, 1 times 7 is 7, 3 times 5 is 15. Those do not simplify. That's my answer. Now B is a little bit different. 6 and 3 can cancel. 6 divided by 3 is just a 2. So when I write my answer, multiplying across, I get 2x. Multiplying across on bottom, I have an x minus 1, and that is my answer. If you need to pause the screen and copy the complex, do so now. Otherwise, we are done with our multiplying and dividing page.